says to take the derivative of a product of two functions, we end up with a derivative that has two terms. It's got a plus in it. Right? And in one of those terms, one of the factors gets differentiated, and one of them gets left alone. And in the other term, it's the other way around. So the derivative of u times v is the derivative of u times v plus u times the derivative of v. And so the goal of integration by parts, as Connor is saying in his response, the goal is that it really is a outwitting of the product rule. It is an attempt to run the product rule backwards, which creates some interesting technical challenges, as we'll see. We want to pick on one of the terms on the right-hand side and say, well, how can we run this derivative process backwards? Because we can't expect, as we expected with substitution, we can't expect that our entire integrand is set up to look just like the right-hand side over here. Right? Because most of the integrands that we're going to care about are an integral of just a product of two functions and not the sum of a product of one's derivative by the other and vice versa. So let's just single out one of the terms on the right-hand side and then try to go backwards. So the antiderivative of something that looks like u times v prime is going to, first of all, have that first term u of x times v of x on the left-hand side. But then the other term, we have this term here in the middle, u prime of x times v of x, that we have to account for somehow. And so we have to move it to the other side of our arrow, in a sense. And to do that, we have to take it apart from the sum with which it is put together on the right-hand side and make it a difference instead. Right, so I'm just moving that other term, this one, over to the left-hand side. But the issue is, in doing so, we have moved it from one side of the antiderivative arrow to the other. We can't do that for free. So we have to remember that that thing, which was on the right-hand side before, still needs to be anti-differentiated in order to move it from the right side to the left side. In other words, we need not that term, but the antiderivative of that term. And so the formula that emerges for integration by parts has not only two terms in it, which is unsurprising because so does the product rule, but it also doesn't tell us exactly how to find this integral, but it tells us how to rewrite this integral in terms of another integral. So this is the formula that Rogowski in the book shows you for integration by parts, that the antiderivative of u times v prime is u times v minus the integral of u prime times v. So the integral that you start with is probably, hard or challenging, or at least we don't know how to do it. And the hope of integration by parts is that the integral that we trade it out for is easier. Otherwise, we haven't made any progress. And it's entirely possible when doing integration by parts that if we make certain choices that are maybe less optimal than others, we might end up with an integral on the right-hand side that is just as hard or maybe even harder than the one we started with. But integration by parts is really, it's a trade-off more than it is a formula. It's trading one integral for another integral. And hopefully the one that we've traded for is easier to evaluate than the one that we started with. Questions so far? So here's an antiderivative, and this is actually the antiderivative that I told Group B over here not to evaluate when they were working on the volume of a certain regular solid in the group work a minute ago. And I told them not to evaluate it because at that point we hadn't heard about integration by parts. Now that we have, how could we attack this integral, the product of e to the x over 4 times x? The first thing we have to do is make a choice in integration by parts. We have to choose which of these two pieces we're going to call u and which pieces we're going to call v prime. So looking back at our formula for a second, there's our formula down at the bottom. Tell me what's happening to u when I apply the integration by parts formula. What do we have on the right-hand side? We have the derivative, right? So follow the red expressions on the right-hand side. Whatever we choose for u, we're going to be taking a derivative of. What about the rest? What about the rest of the integral on the left? We start with v prime, and when we follow over to the right-hand side, we have instead v. So what's happening to that second piece that we choose? The piece which doesn't become part of u, which gets differentiated, becomes part of v prime, which gets anti-differentiated. So just following what exactly happens to these pieces will help us to develop a strategy that whatever we pick for u is something that we're going to take derivatives of. Whatever we pick for v prime is something we're going to take antiderivatives of. And so the integral on the right-hand side will be easier, which is what we want, if we pick a u whose derivative is easier than u was, And if we pick a v prime whose antiderivative is easier, or at least no more challenging, than the original v prime was. Usually, we seek to make the integrals easier because u prime is easier than u. Sometimes the antiderivative of v prime makes it easier as well, but usually it's the derivatives part of it that makes our life easier in integration by parts. So, oops. So in this example, what would you like to choose for u? And why is x a good choice? Well, okay, so I've written this one to be kind of suggestive, right? That, just because it's the first factor in a product doesn't always mean that it's the one we want to choose for u. Because after all, multiplication is commutative and works both ways. So let's think strategically again. If I pick u to be x, then what's u prime? 1. And 1 is a whole lot easier of a factor to work with in integration than x was. Because 1, we can pull out of an integral. It's a constant. So choosing u equals x would seem to be a good idea because its derivative is much simpler than u was. Okay.
But if we're finding the antiderivative of v, isn't it much easier than the antiderivative of x?
Well, I agree with that. So let's do both choices, but let's first look at this one. Because choosing u to be x forces us to choose v to be e to the x over 4. V prime, rather, to be e to the x over 4. And so now that leaves us with the question, what's the antiderivative of e to the x over 4? Let me ask Group B, who worked on this yesterday and today. Group B, how did you find an antiderivative for e to the x over 4? You took a substitution, right? You have an inside function, x over 4. I'm going to write this off to the side here. Your substitution went something like u equals x over 4, so that du is equal to 1/4 dx. And so dx is equal to 4 times du. And this integral becomes the integral of e to the u times 4 du. And what's the antiderivative of e to the u? E to the u. That's that function that cares not for your derivatives or antiderivatives. And then to substitute to get back from u's to x's, we find our antiderivative to be 4 times e to the x over 4. Plus c in principle. But I'm going to hide the plus c for the remainder of our integration by parts argument. We'll add a plus c at the very end of our problem here. So the antiderivative of this v prime is 4 times e to the x over 4. And when I'm writing an integration by parts problem, I like to have all these pieces in front of me. My u, u prime, v, and v prime. We started by choosing u and v prime. These came from the original. And then we found u prime by taking the derivative of u, and we found v by taking the antiderivative of v prime. And this antiderivative was a little tricky because it required us to think substitutionally, but it wasn't that bad. So with all those pieces on our plate, what does the integration by parts formula give us for our right-hand side? What are we supposed to have?
X times e or e to x.
Right, so the first term is u times v, and since we have our u and our v over on the right there, we can write them down. So it's x times 4 e to the x over 4. There's our first term. And what follows that? Yeah, u prime times v, then we're going to take the antiderivative of that. Best practice, I should get a dx there at the end. Now u prime is 1. And here's why choosing u to be x was a good idea. Because now this integral that we get, 4 e to the x over 4 dx, no longer has a product of two functions that are difficult to work with. Because one of the factors in that product is now just 1. So when you multiply out the thing that we're now integrating, the thing that we've traded out for, we get 1 times 4, otherwise known as 4. times e to the x over 4. And so to finish this problem, now what do we have to do? Integrate one more time. Luckily for us, though, we've done the majority of this integral already, because we know, based on what we have down here, what the antiderivative of e to the x over 4 is. So as soon as I pull this 4 out of my integral, let's pull this 4 outside. 4 times antiderivative of e to the x over 4. Now the antiderivative of e to the x over 4, according to the box over here, is 4 times e to the x over 4. And so, when the dust settles, we have 4 times e to the x over 4x times e to the x over 4 minus 4 times another 4e to the x over 4. And we'll just write 4 times 4 to be 16. So we end up here with 16 times e to the x over 4, and this is only missing one thing, plus c. And so there's an application of the integration by parts formula. But I want to, as soon as we finish with this example, I want to talk a little bit more about strategy. How do we choose a u and how do we choose a v? And then also give you a quick little way to organize your work on this, because another potential source of errors in integration by parts is the fact we have subtraction going on here. And having subtraction often leads to making sign errors if you forget parentheses or if you don't distribute correctly, or there's a lot of ways that that can introduce erroneous negative signs or maybe not enough negative signs into your final answers. So a way to better organize your work is the second thing that I want to give you today before you get into your groups and work on this stuff.